This paper is one of two, the third paper, that looked at the standard skin cancer model studied by scientists in a laboratory. It's done in mice. Cancer, fortunately, is a multi-step process. If cancer resulted from a single mutation, we would probably all be dead long ago from cancer. So cancer takes a series of mutations in a specific set of genes to cause your cells to lose control. They lose the constraints. It's actually easy for a cell to eat food and divide. The hard part is for your body to keep your cells from doing that day in and day out. Many of us in this room don't weigh any more than we weighed a year ago, even though we've eaten a ton of food in the interim. And that's a good thing, because if every cell in your body had unrestricted ability to divide and divide and divide, we would all fill this auditorium individually. So it's much more difficult to keep your cells in control than to let them just proliferate ad nauseum. And so cancer happens when those constraints are broken, when your genes can no longer keep a cell from dividing and dividing and dividing. So once a cell breaks those constraints, it is medically a cancer, and it will grow until it consumes you. This paper concluded overall, the induction of antioxidant enzymes by Protandim may serve as a practical and potent approach for cancer prevention. A follow-up paper, about a year later, looked further into the mechanism and showed two of the specific genes that are regulated by Protandim. One is the suppression. Protandim, some genes are turned down, and P53 is one of them. And manganese SOD, that's a mitochondrial SOD, was induced, is turned up. And it was those modulations of those two genes may play an important role in the tumor suppressive activity of Protandim. What are the data shown in that paper? There were two groups of mice, and the first group got a regular mouse chow diet, and it's balanced, it's a healthy diet. They were treated with the two chemicals at high doses that cause skin cancer. That group of 15 mice, shown here in the yellow bar, got cancer. 100% of them, all 15 mice, developed cancers. Many of them developed, probably all of them developed more than one. The number of cancers per mouse, 6.3. The total number of cancers in that group of mice, 94. That second group of mice, treated identically except their mouse chow had Protandim added at a dose calculated to be equivalent to what most of you in this room are taking, 1 caplet a day for a human. And look at the second group, 15 mice. This time, a third of them developed no tumors at all. And if you look at the total number of tumors in this group compared to the other, it's 57% lower, only 40 as opposed to 94. So the cancer incidence was reduced by 33%. The multiplicity, the number of individual cancers, reduced by 57%. This was a remarkable study described in these two papers.